Hello, my name is Antariksa. I am a Master of Library Information Science student at the University of Maryland, College Park. Recently graduated this month. I'm also a librarian at the National Library of Indonesia. And today, my presentation will be about my thesis research project that I have been working on under the advice of Dr. Stephanie Valencia, which is about investigating the usability of an Indonesian Special Collections repository. So, Khazanah Pustaka Nusantara, or Khastara, is a special collections repository built by the National Library of Indonesia to provide access for digitized spatial collections, including ancient manuscripts, newspapers, books, maps, and photographs. The primary user groups for Khastara include humanities students, scholars such as historians and philologists, independent researchers, journalists, and artists to find sources and inspirations for their works. The items in Khastara reflect the diverse ethnicities, languages, and histories of Indonesia. The varieties of collections constitute a strength in the platform, but it also comes with challenges in search experiences and content discovery, such as in terms of the varieties of local languages and a lack of transliterations and translations for many of the available works, which are written in different local languages. So mixed method research was conducted, incorporating methods from HCI and theoretical understanding from the information behavior model of the information search process. And the quantitative element involved surveys using the System Usability Scale questionnaire adapted into the Indonesian language. And the SUS questionnaire here is used because it is one of the most common usability questionnaires to measure the usability perceptions between users. And meanwhile, the qualitative study here consisted of contextual interviews with the representative users of Khastara, as well as librarians. And these interviews were conducted to obtain a fuller picture of a typical user's search experience for the context of cultural heritage. The research outputs include design applications demonstrated in the user journey map, lo-fi wireframe for Khastara user interface, and also a draft metadata application profile for the metadata, which is like a documentation for like what the metadata should look like for like the items on the platform. So in terms of the SUS score, the aggregate SUS study score was 61.72, which is lower than the average SUS score of 68, and this signifies a lower than average usability perceptions in Khastara users. This is I described user search experiences based on the interview data by dividing their activities into the 6 stages according to Kultau's information search process model. And as you can see, I also described their actions, thoughts, and feelings according to the interview data. I added some descriptions about the usability problems and that they experienced during the contextual interviews that they demonstrated during our interactions in the interviews. And most of the frustration, according to the model, the users mainly experience the most frustration in terms of the exploration phase, where their preconceived search queries and ideas about the digital items did not line up with the way that items are organized and described on Khastara. So basically, in terms of general insights, I found that most importantly, users need a lot of background information about search topics, including related works, finding aids, and languages of collections that are available on Khastara. The study results suggest that Khastara's user interface should enable users to explore items through category displays instead of relying on like user type queries. And in terms of the wireframe design, I also emphasize that with more like exploration phase features, and also metadata descriptions should involve information about like languages, topics, and types of collections, as well as physical descriptions and relations to other documents. So in terms of HCI contribution, this research project primarily involves empirical research contributions in user experience for cultural heritage settings. Meanwhile, one of the limitations of this study is the lack of comparable studies combining HCI and information behavior constructs. A research direction from this study about the particular platform is to incorporate the viewpoints of users that are often overlooked in research about digital cultural heritage, such as people with disabilities. How can the usability of special collections repositories, such as Khastara, be improved to achieve universal usability. What is the search experience like for people with disabilities, especially when accessing digital cultural heritage? These are only some of the many perspectives on digital cultural heritage that should be investigated in the future. Thank you. Questions, concerns, please let me know.
Hello, everyone. My name is Yi Zhu, and I'm a third-year PhD student at UMT's College of Information. Sensemaking is a crucial cognitive process in scholarly work where researchers interpret and synthesize information to generate new insights or solve problems. In this process, researchers often face vast amounts of complex and diverse information. Among these, some information like abstract concepts or theories is intangible and hard to be sensed directly. This lack of sensibility has been extensively documented in empirical studies of scholarly sensemaking research works. We are curious how we can make this intangible scholarly information more sensible. We believe that immersive technologies might offer promising solutions. These environments can mimic the physics and affordance of the existing material world, but can also implement novel physics and affordances that augment and extend rather than simply replicate existing senses. However, current research on immersive sensemaking mostly focuses on geospatial data or just the placement of virtual objects in the sensemaking tasks. But how might we augment sensemaking by making the full range of the scholarly information more sensible in immersive environments, especially those abstract concepts and theories? Through a systematic literature review and visits to modern art museums, we developed a design toolkit for brainstorming designs that make scholarly information more sensible. In this design toolkit, we include different types of information objects, their corresponding properties, and visual design patterns. We developed 3 conceptual designs using this toolkit. Given the time constraints, I will only briefly walk you through one conceptual design, which is the first one, the City of Information. This design draws inspirations from visual design patterns such as space, repetition, and compositions to represent intangible properties like connections, similarities, structures, and completeness. Therefore, the City of Information is able to address the issue of overwhelming complex connections between immaterial information objects when solving a research question. For example, evidence and research directions. So, in this immersive design, Sensemaker extracts important concepts from literature and research loads to create building blocks. These shapes enforces structural rules, allowing the sensemaker to visually sense where a building might be conceptually weak or incomplete, prompting them to strategically place additional blocks to strengthen their large structures. Over time, the City of Information evolves into a macro-level sensemaking aid. Taller buildings indicate areas of research that are more evocative to the sensemaker, while the distance between buildings showing their conceptual relevance. When the sensemaker steps into this city, familiar landmarks and pathways guide them, enabling quick navigation through their accumulated insights or quotations. After years of construction, the sensemaker can climb to the tallest building to overlook the vast cityscape, sensing unexplored spaces and opportunities where promising future research directions naturally lies. Besides the City of Information, we generated another 2 conceptual design using our toolkit. For details about rusty text and unshaped matter, you can scan this QR code to access our pictoria or talk with me at our poster session. These conceptual designs show how immersive environments can support scholarly sensemaking, demonstrating our toolkit's utility for brainstorming systems that make scholarly information more sensible, especially the abstract and qualitative data that prior research work often overlook. Although our toolkit is currently focusing on visual designs, future work can extend it by incorporating additional sensory modalities such as smell, haptics, and temperature. Thank you very much for your attention. For more details about this project and myself, you can scan these 2 QR codes. Thank you.
Hello, everyone. I'm Georgia, a first-year master student in HCI program from College of Information. And today, I'm going to introduce IC, a tool for interactive and semantic exploration of scientific literature. Before this, I want to ask a question. Have you ever felt lost in the sea of papers? Imagine you are starting a research project. You get hundreds or even maybe thousands of papers just from a few keywords. Some of them are relevant, some of them are not, and many seem connected, but you are not sure. That happened to us. We were doing a survey project and we collected papers from 19 academic databases. Just from IEEE, we got over 36,000 papers. Even after a strict filtering process, we still had around 35,000 papers left. The papers had a wide range of topics, but it was impossible for us to read or organize them by hand. So we need a better way to understand the relationships between papers based on the similarity of their context. We call this semantic connections. That's why we started building our tool, IC. Instead of leaving you to manually go through paper titles, IC helps to explore the scientific structure of the literature using your own dataset. This idea was inspired by CHI 2024 Papers Explorer and by previous research paper where authors used embeddings to semantically analyze papers. The CHI 2024 Papers Explorer succeed in finding papers based on embeddings, not just from keywords. However, we find that the color by options don't provide meaningful insights, and the score is represented by both color and size, which makes it confusing. These limitations motivate us to think, how can we improve this experience? Then we built the tool. IC has 3 different sections. The primary component is similarity visualization. This component is an interactive map that displays all the paper in the dataset based on the semantic connections. We use a language model to convert each paper's title and abstracts into an embedding. Then, UMAP is applied for reduce the high-dimensional embeddings for visualization. Each dot represents a paper, and its color reflects topic similarity. Users choose how to color the map by year, cluster, venue, or relevance. They can also click on papers to view details and bookmark the ones they are interested in. We also highlight the keywords which users search for in the title and abstract to help users quickly locate relevant information. And the top 10 relevant papers are displayed based on the user's search. The slider near the search bar allows users to adjust how closely should results match the query. Users can also control the number of clusters shown on the map. By adjusting the number of clusters, they can zoom in from broad domains to more specific subtopics. We use the k-means method to organize similar papers together and reveal semantic groups. The number of clusters is flexible, so users can choose how detailed they want the group to be. Each color represents one cluster. This helps users quickly identify groups of related work without having to read each paper individually. The second component is advanced search. It helps users narrow down papers by year, venue, area, or author. A bar chart shows how many papers were published each year, giving users an idea of when certain topics were more active. The third component, History Dashboard, records what users do. It shows recently viewed papers, bookmarked papers, recent activity, and search history, which makes it easy for users to go back to interesting ones. Moreover, we support uploading custom datasets. Users can explore their own paper collections by uploading a CSV file. So, in summary, HCIL helps users explore, filter, and revisit relevant papers more effectively. And in the future, we will be adding export options and descriptive cluster summaries to help users quickly understand what each group of papers is about. Here's a link to the project. Thank you all for your time and for listening.
Good afternoon, everyone. My name is Xiaoyu Liu, a first-year PhD student at the Human Data Interaction Group. In this talk, I'm going to introduce our ongoing project, Infographics. What do we mean and what do they show? Infographics stands for information graphics, and as the name suggests, people have been using them to communicate all kinds of information and data to the intended audience, often for journalism, research, and education. There has been a wide variety of infographics circulating on the internet, and there has also been an ever-growing stream of visualization research focusing on this particular medium. However, behind all this boom of infographics, do we really have a clear idea about what makes infographics infographics? Let's take a look at some examples. Does this image look like an infographic to you? What about this one? And this one? While everyone might have their own answers to these questions, I think we can all agree that these pictures look quite different from each other in terms of their content and structure. And it also turns out that while some papers think these images are infographics, others actually do not. There's a disagreement here. What is going on? In order to figure out why people are making such confusingly diverse comments regarding infographics, we decide to look for some papers that can explain the design space of infographics. Unfortunately, almost all papers that we could find have already reduced their scope to a certain subset of infographics. For example, some would exclusively use timeline or proportional data, while others would employ animation and gamification as specialized presentation strategies. Yet another paper, despite looking at infographics in general, would only explore the customization of data marks instead of all dimensions of their authoring and design. Based on these limitations in existing work, we want to formulate a design space for infographics that can encompass their definition, design, and application. More specifically, we want to explore these research questions. What do people mean when they use the term infographics? How do people perceive them in relation to other kinds of visualization topics? How do people encode data using visual elements when they're designing infographics? And in what domains and ways are people using them in real life? We anticipate that a clearer definition and a more comprehensive design space for infographics will allow for future researchers and designers to produce more effective infographics and better tailor them to the appropriate domains and audiences. In order to gather data and insights towards these research questions, we conduct 3 phases of study of different modalities. In the first phase, we conducted a full literature review that covers all 4 research questions. We will start by performing a keyword search in major visualization conferences and journals for papers that mention the term infographics. And then we would manually extract any statement or figure within these papers that, with regards to infographics, either gives a definition, provides an example, or compares and contrasts them to another type of visualization concept. Finally, we'll perform a 2-round inductive coding to to obtain any emerging theme or connections within these statements. Through this procedure, we extracted a total of 487 statements and 111 infographics-related figures. And based on this sentence corpus, we were able to retrieve 102 different codes. These codes are categorized into 14 high-level categories, each of which describes one of 6 aspects of infographics: design, goal, content, authoring, application, and comparison. Among these, we noticed that there are some codes that are actually conflicting with each other, which highlights potential disagreements between them that we want to investigate further. In the second phase, we will conduct an image analysis on all the figures that we retrieved from the first phase. This targets research question number 3. After splitting up all the composite figures and filtering out low-quality samples, we end up with 357 individual infographics in total. They will be analyzed based on their usage of marks, encodings, compositions, and layouts. Some examples are shown here. Finally, we'll distribute an online survey to gather first-hand insights from domain professionals in science research, business, and education. This is expected to contribute to research questions 1, 2, and 4. The survey will gather their opinions about the definition, boundary, and application of infographics to complement our findings in the literature review. This project has been an ongoing effort. At this time, we have successfully completed the literature survey and data extraction. In the coming month, we will focus on the image analysis and expert survey. Thank you for listening.
So we are going to present projects rolling into the future, navigating career pathway with a GenAI model and a power pool world model. So because most of you are still students. As students, we got a feeling. For example, this year we are year 1, next year we are year 2, that's the third year we are year 3. So we are like very linear, step-by-step procedure. However, when we really leave the school and when we start on the job markets, like when we start in our career, actually it's very noisy. It's like a non-linear process. For example, sometimes we just got really good for 2 years, but suddenly the whole product is cancelled. And then we need to move on to some other product teams, or we want to go back to school, sometimes like that. So there is a challenge of non-linear career paths. So it's very severe for people, especially for people in early career who just got used to the education, the linear education, but not the real world. So we try to use analogical mapping to map that to a podium. Because as I mentioned, the real world is very messy. There are many factors influencing each other, intertwined with each other. So we want to use a podium, which is everybody knows that, how to play with them, try to map the real world. So for example, in a podium, we know the general direction. For example, we want to be a software developer or we want to be a UX researcher, but we don't know the actual details of the position. What's maybe the job responsibilities until we really take that job. So it's kind of like the podium. So we know the direction to notch the ball, but we don't know what's the details of that. And another thing is that's kind of a non-linear process. And when you try to do something in the real world, it will just change the real world in certain ways. For example, it will just change your social circle. It will just change your profiles, your previous experience.
Okay. So this is a game interface for our poll world model. You can see a virtual poll table on the left. Each ball on the table represents either a major event or a random event that you may encounter during your career life. On the right, there is a timeline showing the major events and the random events that happen during this run, such as human-computer interaction lab drawing or a career path hesitation.
And we are trying to use large language model is word knowledge to generate all kinds of events in a certain tree. For example, people input their profiles and we want to generate so their future tree events, either positive or negative. However, a problem for the current language models, especially in their training data, in the pre-training data, is that there is a very severe severity bias. For example, we know the language model is trained with all the data on the internet. However, on the internet data, most of them, they are like positive, their success, because people are hesitate to share their failures. And like, because, for example, Jessica also has share the idea of failure, the CV of failures, but that's just a small portion of the whole internet. So we are trying to fine tune the language models to make the success and failures is more reflective to the real world. So just a very small portion of success and much more failures. So we are using like a real world experience. For example, this one is from when I did a master's degree like 7 years ago. And you use that to fine tune the large language model. And the process is when the user put their profiles, their previous experience, and also their career goals. And with the fine tune language model, we will generate 5 different random events. Maybe the user, the participants won't encounter all the random events, but they will encounter some of them. And when they experience some events, we will then generate the milestone balls. So the milestone is kind of after 1 year. And we have a 2-year period. And for each noting, it takes some time. For example, each noting, when the strength is larger, it takes 10 days or 20 days. So we are recruiting our participants. If you want to experience our game, please scan the QR code. Thank you.
Good afternoon, everyone. So, like we were just introduced, we are the Rewatch Play HCIM capstone team, and we were invited by Dr. Carol to present some of our designs today. We were able to design a platform specific to the pedagogy that she has created called Read, Watch, Play. So some background information. Read, Watch, Play is a pedagogy designed with play as the primary method of exploration and learning. Furthermore, the pedagogy is designed to be flexible for course content itself. However, existing platforms such as Canvas, which you may know as ELMS, are often difficult to learn and use for instructors and students alike. So our team was tasked to design a teaching and learning management system, TLMS, for the Read, Watch, Play pedagogy to support both instructors and students to have a more streamlined experience. Our process worked in 4 parts. We'll discuss them in this order, but it was not a linear process. So we conducted user research, ideated based on research and feedback. We tested our designs, and finally we created the prototype. So for the user research, we involved a lot of instructional team interviews to understand the RWP pedagogy in practice. So we interviewed with instructors who had incorporated the pedagogy to varying degrees. We also conducted 2 student focus groups to understand what are the major pain points of being in an RWP-based course for students. And finally, we involved some TAs and graders as well to understand what are the unique challenges and needs of these students who are in between instructors and students.
After our user research, we translated our key findings into how might we questions. For example, how might we make course designing more intuitive for instructors? We started by brainstorming as a team, sketching ideas, and mapping out user flows based on the research insights and the personas we had created. To build on top of that, we co-designed with Dr. Caro and Professor Kendall, not only to collect requirements, but to understand how they would like to interact with the platform and what kind of flows they would like most be useful. This input was extremely valuable and helped us guide into low-fidelity prototyping. We created low-fidelity prototypes on Figma, focused on the code tags. For example, in this slide, you can see the flow for finding and submitting an assignment. There are multiple ways a user can reach and complete an assignment, depending on their workflow and preferences. To validate these designs, we conducted 5 tests with students and 5 with instructors, collecting feedback on the overall experience, navigation, and layout and usability. These were some of the findings from our user testing. We found precepts helped instructor build course faster. Students found the app very intuitive. Instructor request better multitasking, and we removed live class interaction based on the mixed feedbacks we received during our user testing.
Now, let me take you through the mobile and web prototypes that we designed for the platform. Here, you can see the home screen of the mobile version from a student's point of view. As you can observe, based on the findings from our user research and testing, we developed a playful and intuitive design system. Our home screen displays the upcoming tasks, assignments, and classes in a calendar view. And a specific feature I'd like to highlight is the read, watch, and play cards that resize themselves based on the ratio of their maximum points within a module, respectively. Here, I'd like to show what viewing assignment details would look like from a student's point of view and what submitting an assignment would look like. Another feature I'd like to highlight here is the assignment details drag feature, which allows the student to quickly refer to the details while making a submission attempt. Now let me take you through what viewing and responding to a submission grade and feedback would look like. We've shown an example of a reading reflection where the instructor can leave annotated feedback and the student can respond to it for further clarification. We've also shown what annotations on read, watch, and play assignments would look like. And finally, this is what submitting a group assignment would look like. When enabled by the instructor, the students are able to create their own groups and submit the assignment as a group. Moving on to what the web view would look like from an instructor's point of view, here's a quick walkthrough of what creating a new module would look like. I'd like to highlight how there's an overview of the existing modules and assignments in the right side for easy access to refer to while creating new ones. As we mentioned earlier about course presets, this is what it will look like to create a new preset, and I will walk you through how it can be used and applied to a new assignment in the next slide. While creating an assignment, the instructor can pick a module it's supposed to be in, whether it's a read, watch, or play assignment, and the rest of the details, and choose a preset before publishing it. Finally, here's a QR code to our case study if you'd like to learn more. Hope you enjoyed our presentation. Thanks for listening.
Okay, hi everyone. Just 2 more sessions to go, so let's pump up our energy. My name is Ajin. Well, we're more like Team Caro. We are all the students who took Caro's games as emergent experiences this semester. I'm a first-year PhD student who just passed first year reviews. Maybe second-year PhD student, yay. And this is Yabing and Sai, who are HCIM students. So today we're gonna do a very funny presentation, which is a satire on gamification and our higher education system in general. So our title is The Ethics of Engagement When Gamification of Learning Works Too Well. So this kind of interesting comical idea emerged from a class activity created by Shruti, Arjav, and Lei in our class. And that week we were discussing about gambling mechanics, how we are so addicted to games, right? And then we were thinking, okay, everyone loves gamification. Honestly, everyone talks about, let's gamify all this. Let's gamify our learning experience because it's going to work. It's going to be really fun. Students are going to be engaged and highly motivated. But does it really work in formal education? Especially, what if gamification with all this addictive behavior and manipulative behaviors reinforces the same exploitative or competitive behaviors we've already conditioned to navigate, especially within traditional grading systems? And before we move on to the actual proposal that we did in class, I want to introduce some terms here. So gamification really means introducing game-like structures, mechanics, and rewards in otherwise non-game-based environments and interactions. For example, those points, those badges, those leaderboards, those challenges or feedback loops actually, did you know that they are all gamification mechanics? And it's often used to increase engagement or improve user experience. And we often have this like rosy ideal picture that, oh, it's gonna really work well. And some of the examples of gamification in practice are, like you all know, like Kahoot, Duolingo, actually even Starbucks rewards. You feel like, oh, I'm gonna get 50 Starbucks rewards, like the stars, to get one matcha latte. And that basically manipulates you to go to Starbucks again and again. And so we're gonna ask, like, all the grading systems, all this like seemingly autonomy allowing system in our higher education. Oh, you can just choose the topic of your paper and we're gonna reward you with the highest points. Do you think this will actually work? What if gamification is really implemented to the core in our higher education system? Would it really work?
And before we go to our design ideas, just some quick relevant gamification terminology. So a bet is the act of placing a sum of money on the chance that a specific outcome will happen for in a future event. And a parlay is a series of individual bets which are grouped and counted as all or nothing. For an individual to win a parlay, they must win all the bets grouped within the parlay. So for example, I can place a parlay with 3 bets: that Jin will wear a dress to the HCIL Symposium, that Tingwei will not be able to attend, and that UMD will be hit by a tsunami today. And so for me to win and get any payout for this parlay, all 3 of these bets must come true. I must win all 3 of them. So for our first design idea is, will your friend get an A? So by leveraging the social connection, students will be empowered to participate in their peers' learning in a gamified, unprecedented way by betting on their classmates' grades. So in the first example, I can bet high on Tingwei to do well. And so this will enforce Tingwei to keep up her good grades because she sees that I have trust and faith in her. In example 2, maybe I will bet low on Shruti to do well. And I will leverage my social connection to her to convince her to stay out late and not study. I'll tell her, don't worry, I haven't started the assignment either. And this will make her do poorly, so then I get my payout. And finally, if everyone bets against your success, that might work as motivation for you to do well and win against the odds.
The next design idea was to bet on whether your friends would make it to class on time, and that would be based on factors like their personality and other common challenges. This would encourage participation as well as their attendance rates. For example, I know that Ruben is a big foodie, so I would bet high on Ruben to be late for class because I know there's a ramen stop on the way to class. In the second example, I would bet high on Shruti to be late because she's a social butterfly and would probably talk to every person on her way to class. And in the last example, I would bet low on Arjav to be on time because I know he's a night owl and would probably be late. So this would help him prove me wrong and come to class on time. In our next steps, we would definitely be implementing the gambling addiction, gamification stuff of education into the info courses because we know gambling is addictive and we want to help everybody with their education by making education addicting as well. Thank you.
By the way, this is a satire, okay?
Hi, everybody. This will not be nearly as funny as the last one. I'm Kara Williams-Pierce. This is Haley Park, and this is Ajin Sim, and we are presenting on the shape of trust in formal education. And you might ask, why trust? So here's why, starting from the beginning. The goal of formal higher education is to support learning. One powerful way to support learning is to leverage play. But learning through play is about risk-taking, failure, feedback, and constant iterating and testing. And the first time you students come into my class saying things like the goal of this class is to go all the way to the edge of the cliff and maybe fall off, that's not something that students want to hear. Students actually need to trust me or trust the instructor to really take risks and embrace failure. Students need to trust the instructor in order to be able to learn, especially through play. So, what is the shape of trust in formal ed? So some brief methods. This data collection occurred during a 14-week fundamentals course in an HCI master's program not to be named. There were 68 students across 2 sections. And we had 5 different surveys that we borrowed, adapted, or created using a number of different pieces on trust to compile our full model. Each week, we administered 1 to 3 of those surveys, and now we're going to walk you through the model that we created. So the overall trust experience of a student is influenced by numerous factors. There's what they bring with them, the inter-individual differences in personality, and then there's what is there in the classroom that's part of the situation to situation variation. So what they bring with them is considered their general propensity to trust, that's survey 1, but they also bring their past history and experiences with education and formal learning, that's survey 3. Once they're in the classroom, there are a variety of components that contribute to whether or not they trust me and their overall trust experience. This includes the perception of me as the instructor, the trustee, as well as their relationship with me. And this relationship occurs within a very particular context, a contextualized incentive structure. Students are incentivized to get an A. They've been trained, right, to be incentivized by A's, and they consider me to hold the A's and be the one that can give it to them. So that power influences every facet of our relationship. Within that incentive structure, there are 3 main components: closeness, the power relationship, that's part of our social interdependence, and what I call cognitive interdependence. Now, cognitive interdependence is where the learning comes in. This is where learning happens. It's a careful balance of information and certainty that leads to productive cognitive conflict within the learner. So this conflict, this is where all the learning happens, but the students have to trust that if they take this leap of faith off the cliff, it will result in them gaining what they want in their future, which is not just the A, but also future learning and career goals. So, in our 5 surveys administered across the semester, what are we finding? These are the preliminary results.
Thank you, Carol. Hi, everyone. In this survey, we measured the students' general trust using questions on honesty, kindness, trustworthiness, and reciprocity. With a mean score of 3.46 out of 5, students were grouped as highly, moderately, and not trusting. And then most fell in the moderate range with more highly trusting than not. And honest and trustworthiness showed the strongest correlation. Those who saw people as honest also view them as trustworthy. The weakest link was between trustworthiness and reciprocity. With this baseline, Eugene will explore their trust tendency in educational setting.
Okay, so part 3 was about educational history, dispositional propensity to trust in formal learning context. We're going to look at student perceptions of this class based on our survey data. So as you can see from this chart, these are just some of the sample questions from the spreadsheet. Students think this professor is not like other professors that I've had, or the activities we do in class are not like other activities we do in class. The rules of this class are quite unfamiliar. So basically, this class and this instructor is highly unpredictable and a little bit uncertain. But let's go to part 2 survey. This is about grades and power. What's really interesting and striking here, especially as we reflect on the insights that we gather from survey part 3, is how empowered students feel. They say, I'm actually not nervous when trying new activities in this class. I actually think I have the power to determine my own grades in this class. I'm also even willing to engage in challenging and difficult activities for this class, and I trust that my grades will be fair, which is quite interesting, right? Like the class structure, the instructor's style, the assignments, all of it is quite unusual, even to some extent a little bit quirky to them, and yet students are still choosing to take risks, and they're challenging themselves because they feel powerful over both learning experiences and grades, and they're even more than willing to do that. It's not like they're forced to do it, but they want to trust and they want to challenge themselves. So, why is that so? Why do you think they will trust that?
One of the potential reasons for students' willingness to take risk in their might be their high trust in the professor. So ratings for professor covering familiarity, competence, kindness, closeness, and similarity averaged around 4.1, which is higher than the general trust mean of 3.46 of earlier. And in this last graph, students consistently rated the professor highly in the areas such as friendliness, competence, and fairness, where more personal factors such as closeness, similarity increases slightly over time. These results within our earlier trust model signal an opportunity for future research on how students' perception of and then their sense of closeness to the instructor influence and are in interplay influenced by a play-based learning environment and shape their overall trust experience.